Now we're going to take a look at the inverse of the addition of logs. We see here we have a log base 11 of 2 times 11. That time symbol here means that we can split this up into two logs that are added together. So when it's log base 11, we split it up into two logs with base 11. One term, our 2, and then our other multiplied term, our 11, with an addition sign between the logs because we were multiplying the main terms. So log base 11 of 2 times 11 is log base 11 of 2 plus log base 11 of 11. Now when you see log base 11 of 11, you know that that's the identity. So this whole thing is just going to reduce to 1. And then our other log we can't do anything with, so that's just going to stay as it is. Next one, log base 2 of 17a. Well, we see that we have a log here, base 2, and 17 and a are being multiplied. You don't see the time symbol, but they are being multiplied. So you can write log base 2 of 17 plus log base 2 of a. Again, our base never changed, and because we are multiplying, we have a plus sign. Finally, log base 10 of t squared plus 3t plus 2. Well, we know that this has no multiplication, so we can't do anything. However, if we do a little bit of factoring, we can create some multiplication. This quadratic factors down to t plus 1 and t plus 2. And now we have two terms that are being multiplied. We have a log base 10 that we're working with, so we're going to make sure that when we split it up, we have log base 10. And so log base 10 of t plus 1, that first term, plus log base 10 of t plus 2. Again, we never changed our base, and that multiplication became a plus sign when we split it into two logs. Now let's take a look at these problems. Given that the log base 8 of 11 is approximately 1.2, and we have a whole bunch of other logs defined for us, find the log base 8 of 660. Well, we don't know anything about log base 8 of 660. However, what we can do is we can split this up into smaller logs. So let's look at the numbers that we're given. We're given an 11, a 10, and a 6 to work with. So I know that there's a 10 that goes into 660. So divide it by 10, and I have 66 times 10. I also know that 66 has a factor of 6, and it also happens to be multiplied by 11. So 6 times 11 times 10. And I have all of these numbers here. All I need to do now is use the addition of logs property, the inverse of that, to split this up. So I have my log base 8, and I have a couple multiplication signs that are going to become a couple addition signs. We split it up here. That first term, we have log base 8 of 6 plus log base 8 of 11 plus log base 8 of 10. Again, the plus signs in here from where we were multiplied. And now, since we're given all of these logs, or at least approximate values of these, we take those numbers, substitute them in, add them up, and we're going to get approximately 3.2 as the solution to the log base 8 of 660. Next one here, same thing, we're given a few logs that we're defined with, and we need to find the log base 5 of 196. Well, let's see, we have a 4, a 6, and a 7. I know that it's at least divisible by 4 because it's an even number and it's 4 less than 200, so I know that it's going to be divisible by 4. So let's go ahead and do that. Log base 5 of 4 times 49. That's what you get when you divide 196 by 4. Let's see, what other terms do I have? I have a 4, a 6, and 7. Alright, well I know a 7 squared is going to be 49, so I can break log base 5 of 49 into 7 times 7. So now I have 4 times 7 times 7. I ended up not needing this 6, and that's okay. You don't have to use every term provided. Sometimes there are extra values given to you. So I'll look at my log. I have log base 5. I have multiplication signs between these. So when I break it up, I'm going to have 3 separate logs, all log base 5. and I'm going to have plus signs between them all because I was multiplying the terms inside of one log. Since I'm given the values of log base 5 of 4 being 0.9 and log base 5 of 7 is 1.2, I plug those in down here, and then I just add them up together, and I get an approximate value of 3.3 to my original problem of log base 5 of 196.